Hello chemistry student, this is Mr. Worley here with you again. Today we're doing chapter 7-3, using chemical formulas. Let's check our objectives out. We want to calculate the formula mass or the molar mass of any given compound. We want to use molar mass to convert between mass in grams and the amount in moles of a chemical compound. We want to calculate the number of molecules, formula units, or ions of a given molar mass of a chemical compound, and we want to calculate the percentage composition of a given chemical compound. This is all about crunching the numbers. It's going to be great. We're going to do a lot of problems. Your lecture exercises are page 244, 1 through 5. That's a section review questions, as well as sample problems F, G, H, and I, which we will do in the lecture. Make sure that you have your textbook. In this case, I've got the photocopy variety. Paper to do problems on and take notes. This is the paper you see on the screen is Mr. Worley's paper. Yours should be a full sheet of paper labeled with your name, the class, the chapter 7-3, and the problems. Be sure to take notes as well. Also, make sure you have at least 2 colors of writing utensil, one for notes and one for section sample problems. I've got green for sample problems, and I've got black for notes that I may take. All right, class, here we go. Let's start reading. As you have seen, a chemical formula indicates the element as well as the relative number of atoms or ions of each element present in a compound. Chemical formulas also allow chemists to calculate the number of characteristic values for a given compound. In this section, you will learn how to use chemical formulas to calculate the formula mass, the molar mass, and the percentage composition by mass of a compound. Formula mass. So, in your notes, you might choose to write down just a little place where it says formula mass. What is formula mass? Because this looks like both a vocab word and a concept you need to know for your chemistry. In chapter 3, we saw that hydrogen atoms have an average atomic mass of 1.00794 atomic mass units, and that oxygen atoms have an average mass of 15.9994 AMU. Like individual atoms, molecules, formula units, or ions have characteristic average masses. Mr. Worley, what's the difference between a molecule and a formula unit? All right, a molecule is a covalently bonded system of atoms. It's a covalent bond. A formula unit is the ionic bond where they're not sharing electrons, but they've traded them, and so they get clumped together in a orderly system. For example, we know for the chemical formula H2O that a single water molecule is composed of exactly 2 hydrogen atoms and 1 oxygen atom. The mass of the molecule is found by adding the masses of the 3 atoms in the molecule. In the calculation, the average atomic mass has been rounded to 2 decimal places, and this is important. When you do your homework, I want you to do 2 decimal places. Okay? Let's keep moving. Here's an example of how they did that one. And this is the long, drawn-out version, but it is still helpful to look. Average atomic mass is 1.01 AMU. Mr. Worley, where did they get that number? They got it from the back of the textbook in the periodic table. Average atomic mass of oxygen is 16.0 AMU. They got that from the back. And they're using the full-blown formula, 2 hydrogen atoms times, here's a conversion factor, 1.01 AMU. For every 1 hydrogen atom, they cross out, and you get 2.02 AMU. Mr. Worley, couldn't we just, do that quick on our calculators? 2 times 1.01, 2 AMU, plus the 16 for the oxygen. Do we actually have to write all this down? The answer is yes and no. Yes in the beginning, no in the future. So the average mass of the molecule is 18.02 atomic mass units. The mass of a water molecule can be correctly referred to as the molecular mass. The mass of 1 sodium chloride formula unit, on the other hand, is not a molecular mass because sodium chloride is an ionic compound. Oh yeah. Guys, I'm looking at a great quiz question here. Difference between molecular mass and the formula mass. What is the difference? It's about ionic and covalent compounds. The mass of any unit represented by a chemical formula, whether the unit is a molecule, a formula unit, or an ion, is known as the formula mass. The formula mass of any molecule, formula unit, or ion is the sum of the average atomic masses of all atoms represented in the formula. Vocab word. All right. Okay, guys, let's continue on. Please move to page 238 for me. I'm going to do the same. And I'd like you to please go to the next video.